Now, a palm fruit dropped to the ground from the top of a tree 45 meters tall. So the first thing you want to do is to write your parameters. And the parameter says 45 meters tall. That is the height, which is also the distance covered, 45 meters. How long does it take to reach the ground? So we are looking for the time. The time is unknown. A palm fruit dropped to the ground from the top of the tree, and that means our unit is going to be 0, because the palm fruit was at rest before it eventually dropped. Alright? So that means the initial velocity is 0. And the question says, how long does it take to reach the ground? And anytime an object is moving vertically, just know that your g will be involved, which is the acceleration due to gravity, which is g. So our g is going to be equal to 10. So the formula we are using will be s plus half gt squared. So if you key in the parameters given, you have 45 equal to 0 times t, which is all 0, plus half times your g is 10 times t squared. 2 cancels t, you have 5, 2 in 10 is 5. So 0, you have 45 equals 0 plus 5t squared. So you have 45 equals 5t squared. Divide both sides by 5. 45 divided by 5 is 9. So you have t squared equal 9. So you find the square root of both sides. And the answer is 3, 7. That's the answer. Therefore, D is the correct answer. Number 2. Now, this is a circuit. And in this circuit, you have 4 resistors. You have 3 ohm resistor, you have another 2 ohm resistor, you have 2 ohm resistor, you have 4 ohm resistor. And the question says, what is the resultant resistance of the circuit in the diagram? The question is simply saying, what is the effective resistance in this circuit? So if you look at this circuit, the current coming here, when it gets to this junction, it will split into 2. That is to let you know that this 2 is in parallel to this 2. Because there is a junction where there will be a separation here. And then when a part of the current, so let's say a current I is coming, by the time we get here, I1 moves to this side, I2 comes to this side. Why? Because when resistors are in parallel, same voltage but different current passes through them. But when you have resistors in series, you have same current passing through but different voltage. So because they are in parallel now, different current, same voltage. So, but when the I1 that enters here goes through like this, and it's about busting out from here, and then it connects with I2 that is coming here, and this junction they meet again to confirm to you that they are in parallel. All right. So this is standing, so we can label this as our R1. This is our R2, this is R3, this is R4. So my R2 and 3 are in parallel to each other. So I have to first align this in parallel and make it a single resistor or a single resistance. Once I get the value, the R1, the one I get here and this, they will now be in series to each other. So let's sort out this parallel, and the formula for parallel resistance is 1 over R2 equals 1 over R1 plus 1 over R2. So for us to get this, it's going to be 1 over R total equals to 1 over 2 plus 1 over 2. And that will be 1 over 1. That is half plus half is 1. So that means your R total is 1 over 2. So if your R total is 1 over 2, and you have 3 ohms here, so they are now in series to each other. And the formula for series resistance is R total equals to R1 plus R2 plus R3. So this is our R1, so that would be 3 plus, the total here is 1 plus, this is 4. So altogether 3 plus 1, 4 plus 1, that is 8 ohms. So in total, the answer is 8 ohms. And this is the answer, option C. Let's look at the next question. Number 3 says, a 24-volt potential difference is applied across a parallel combination of 4 6 ohms resistors. The current in each resistor is dash. So look at the question again. A 24-volt potential difference is applied across a parallel combination of 4 6 ohm resistors. So you are going to draw a parallel arrangement of resistors. Now this is a parallel arrangement. Now let me quickly say this. If you have issues with series and parallel arrangement, you can check the description. You will see a link to the video on electricity where I discussed resistors in series and in parallel. However, let me quickly just do a little recap of what I discussed in that video. Now, if you look at your electric wire, right, that carries your electricity, the cables that carries electricity through your street or your house, you'll see that it's something like this. This is how the cables are. And that is what we call parallel. So they are in parallel. So if anything happens and 2 of these cables touches each other, something can happen. There could be a spark, right? So when you talk about parallel, this is the meaning of parallel. So when the question says 4 resistors are in parallel, this is the meaning. But when you say series arrangement, they are all on the same line. So if it is series arrangement, you have something like this. So this series. Now your resistors can be represented with this symbol. It can also be represented with this symbol. Alright? So let's go back to the question. 24-volt potential difference. So I'm going to have my battery. I have it somewhere here, 24 volt. So look at this. For parallel resistors, I mentioned earlier. Now look at it. For parallel resistors, arrangement of parallel resistors, different current flows through, but same voltage. Different current, same voltage when they are in parallel. So this is your R1, R2, R3, R4. The question says a 24-volt potential difference is applied across a parallel combination of 4 6 ohm resistors. So this is the first one, this is the second one, this is the third one, this is the fourth one. They are all in parallel to each other. And this voltage is passing through. So, because the rule says for parallel resistors, different current but same voltage. So that means this 24 volt is passing through here, passing through here, passing through here, passing through here. And the question now says the current in each resistor is what? There are 2 ways you can answer this question. I'm going to use the 2 and we will get the same answer. You can, for those of you that are writing the JAMB exam, you are expected to use the shortest possible method to answer questions. So there are some things that are not necessary. It will be a waste of time. As for you to maximize your time, since you know that it's the same voltage that is passing through, you can just go ahead with your formula. V equals IR. Your V is 24 volts equals to your I is your current times your resistance is 6. And then you have 24 equals to 6I. Divide this side by 6. And that is 4. Your I equals 4 ampere. Now, because they are having the same resistor value, the resistance here is 666, that means the same quantity of current is going to pass through. So that means 4 is passing through here, 4 is passing through here, 4 is passing through here, 4 is passing through here. So the answer to the question is going to be 4 volts. But if you want to cross-check to see if what you have done is correct, what you're supposed to do, since this voltage supplies everybody, you can calculate the effective resistance here. When you calculate the effective or total resistance here, you can use that to calculate the total current passing through here. Then you will now divide that total current into each other. So let's check if we are going to get the same 4 amps. So what am I to do? They are all in parallel. The formula says 1 over r total equals to 1 over r1 plus 1 over r2 plus 1 over r3 plus 1 over r4. So that's 1 over r total will be equal to 1 over 6 plus 1 over 6 plus 1 over 6 plus 1 over 6. So my LCM is going to be 6. 6 is 6, 1 times 8, 1 plus 1 plus 1 plus 1. So I'm going to have 4 over 6. Right? I have 4 over 6. So the next thing you want to do, if your 1 over RT equals 4 over 6, you can cross multiply or directly. What is the inverse of 1 over RT? That will be RT. So that means this comes down, this goes down. So that means my RT will be 6 over 4. But so as not to get confused, if you cross multiply, you have 4 RT equals to 6. So you divide both sides by 4. So your RT is 6 over 4. 2 here 3, 2 here 2. And that is 1.5. So 1.5 ohms. That means the total or the effective resistance in these 4 resistors is actually 1.5. So let us now see what is the total current passing through. You know, same voltage passes through. So let's see the total current passing through here. So for us to see, we still use our Ohm's law. This is the formula for Ohm's law, V equals IR. Okay, we want to look for the current. So my R is going to be V over R. What's my total V? 24 divided by 1.5, which is the resistance. If I divide this, my answer will be 16. If you punch your calculator, it's going to be 16. So that is 16 ampere. What does that mean? 16 ampere is the total current flowing through.
Yes.
But because all the resistors are all the same, so I will just divide this into 4.
Exactly.
And that is 4.
Yes.
So 4 is passing here, 4 here, 4 here, 4 in 4 places. That is a total of 16. So that means this calculation is correct. However, because you are trying to save time, instead of going through this route, and you would have spent about 8 minutes to answer just a single question, you can just go through this route to get the same answer. So let me emphasize on this once again. When you see resistors in parallel, same voltage passes through but different current. Now, the reason why we are having the same current is because the value of their resistance is the same. 6 ohms, 6 ohms, 6 ohms, 6 ohms. Didn't mean we have, maybe we have, if we had something like 2 ohms in parallel to 3 ohms, in parallel to 6 ohms. So if you had a situation like this, 2 ohms, if we had a situation like this, the same current will not flow through. Why? The higher the resistance, the smaller the current. Resistance means opposition to the flow of current. So if the resistance is large, little current will be able to pass through. If the resistance is little, big current can pass through. Let me give you this illustration. If somebody invited you for a birthday party, all right, and the person said this party is strictly by invitation, you were given an invitation and then an IV invitation card, and you got to the venue of the event and you saw a bouncer, a very huge bouncer at the entrance, and the bouncer is asking you where is your IV before you can gain entrance. You will agree with me that because there's a huge bouncer at the entrance, many people without IV will not be able to enter. Even if a few will enter, it will be very few, maybe some children, because the guy is huge, some children can easily run through and enter. But let's reverse it. If the bouncer at the entrance is a small boy,
Just like that.
yes, just a small boy, a primary 1 child is the bouncer at the entrance, and the boy is saying, nobody will enter until you show me your IV card. What will happen? People will move in and they will enter. So you agree with me that if the resistance is small, more people can come in, right, without the IV. But when the bouncer was a huge guy, that means the resistance was big, only little current we pass through. So resistance is simply the opposition to the flow of current. So when the resistance is large, the current will be low. When the resistance is little, the current will be more. So back to this. So if this had been the arrangement, you will agree with me that because 6 ohm is a bigger resistance than this, more current will pass through here than here. Are you with me now? More current will pass through here than here. But now that they have the same value of resistance, which is 6 ohms, then the same amount of current. And that is why this 16 will divide equally into 4 and it's going to be 4. So that is the answer to the question. Let us look at the next question. Which of the following is the dimension of pressure? The dimension of pressure, what is the formula of pressure? Pressure is force per unit area, which is force over area. So if that is the case, what is the formula for force? Mass times acceleration divided by area, which is distance times distance, which is meter times meter, right? Meter squared. The SI unit of mass is kilogram. So kilogram times SI unit of acceleration is meter per second squared divided by meter squared, which is area over 1. So I can rewrite these as kg times meter per second squared times 1 over meter squared. So meter will cancel one of these. So what do I have left? I have kg m minus 1 s2 minus 2. So if you are going to write this in dimension, so this is the SI unit, and from here you can get the dimension. The dimension for kilogram, which is mass, is capital M. Dimension for distance is n minus 1. The dimension for time is t minus 2. So the answer is ml minus 1, t minus 2. That's the answer. Number 5. Number 5 question says, which of the following has same dimension as moment of force? What the first question you ask yourself is, what is moment of force? Moment of force is simply the product of force and distance. That is the formula for force, for moment. So moment of force is the product of force and the perpendicular distance from the point of application of that force about a point. So if that is the case, for moment, the SI unit of force is mass times, the formula is mass times acceleration. So you have mass times acceleration times distance. And your mass is what? Kilogram. Acceleration is meter per second. Times distance is meter. So if you're going to rewrite this, it's going to be this over 1 kg meter squared s2 minus. So the question says, which of the following has same dimension as moment of force? It is not impulse. It is not momentum. Impulse and momentum, they have the same SI unit. So if your answer is momentum, you are wrong. If your answer is impulse, you are wrong. Because impulse and momentum, they have the same SI. So the other option we have here is work done and force. Force is wrong. The answer is work done. So let us confirm that. What's the formula for work done? For work done is the product of force times distance. And this is force, this is distance. So that is work done. And so note this, these three values, they have the same SI unit. Work done, energy, which is potential energy, and moment of force. These three, they have the same SI unit, which is equal to this. So if the question says, which of the following has the same dimension? So let's now write out the dimension. The dimension is going to, that is the dimension of work done, dimension of energy, and the dimension of moment is going to be capital L squared T2 minus. That is the answer. So the answer is work done, not impulse, no momentum. Let's see what the SI unit or dimension for momentum and impulse. Let's see what it is and let's compare. Impulse is giving us, the formula of impulse is force times time. Now, from here, can you see that force times time? This is force times distance. Can force times distance be equal to force times time? No. So let's confirm that. force is going to be Newton seconds, or your force is mass times acceleration. So this is your mass, this is your acceleration, and this is your time. So this we cancel it, and your answer is going to be kg meter per second. Is this the same with this? No. So the answer is not impulse. Let's check for momentum. You remember I told you that momentum and impulse, they have the same SI. Let's confirm that. Momentum is going to be what? Momentum is mass times velocity. Okay. So momentum is actually equals to mass times velocity. And so the SI unit for mass is kilogram. SI unit of velocity is meter per second. So that is kg meter per second. Can you now see that the SI unit for your momentum and the SI unit for impulse are exactly the same? Alright? So that is that about the question. Let's go to the next question. The next question says, which is number 6. It says, an electric kettle connected to a 240 mains, 240 volt mains. That means our voltage, our V is 240, or our potential difference, as the case may be, produces 6.0 times 10 to the power 5 joules. That joules represents energy, heat energy generated. So I can represent it as H, alright? And that is what? 6 times 10 to the power 5 joules of heat energy to boil a quantity of water in 5 minutes. So our time is 5 minutes. And remember, the SI unit of time is seconds. So we have to convert this minutes to seconds. How do we convert it? We multiply by 60. So if you multiply by 60, that will be 300 seconds. Alright? Then the question says, find the resistance of the kettle. So we are looking for R. Now, the next thing you want to do from this parameter, what are the formula that you can use that combines all of these parameters? So we have the formula H equals IVT. H equals IVT, but if you look at the board, there is no I. But you can also still recall Ohm's law, V equals IR. So if I make I the subject of formula here, I'm going to have to divide both sides by R. So my I is V over R, right? So in place of this I can replace it with V over R. So I'm going to have H equals V over R times VT. I have V, I have T, I have V, I have R. So with this, I can arrive at the answer of my R. So let us try to solve for this. So this is going to give H equals V squared T over R. If you cross multiply, you have HR equals to V squared T. Divide both sides by H so that you can find R. So your R is going to be V squared T over H. And then your R is going to be, what is your V? Your V squared, V down to 240 times 240 times our T is 300 all over H, which is 6 times 10 raised to the power 5. Now, take note of this. Most of the questions you'll be given in JAMB, you actually do not need a calculator to answer the question. If you know how to go through it, you actually do not need a calculator to go through it. However, if you are going to use calculator to prepare, make sure you do not use a scientific calculator to prepare. Because when you get to the exam hall on that day, you will not find, or you will not have access to a scientific calculator. So let's see how we can solve this question. So you have 24 times 24 times 3. So if you punch your calculator, okay, so if you multiply all of this, you have 1728. 1728,000. That is 1, 2, 3. 1, 2, 3, 4. 4 zeros. 10. All divided by 6 times 10 is power 5. So what do I need to do here? I'll just divide my 1728 by 6. If I divide that, what would be the answer? 288, right? I would have 288 times 10 raised to power. Now, can you see this 10 raised to power 5? When it comes up, it will become 10 raised to power minus 5. So, if I multiply 288, then 1, 2, 3, 4 by 10 raised to the power minus 5. What I need to do is just to move my decimal here 5 times. That's the meaning of times 10 raised to the power minus 5. So I'm going to have 1, 2, 3, 4, 5. So my final answer will be 28.8. So the answer to the question is going to be 28.8 volts. That is the answer to the question. That is the answer to the question. Of a side of a metallic cube at 20 degrees Celsius is 5.0 centimeter. So that means this is number 7. That means our L1 is 5 centimeters and T1 is 20 degrees Celsius. Given that the linear expansivity of the metal is 4.0, so that is our alpha is 4.0 times 10 raised to the power minus 5 per Kelvin. Find the volume of the cube at 120 degrees Celsius. So if our T2 is 120 degrees Celsius, we are being asked to find the V2. So I repeat the question again. The length of the side of a metallic cube at 20 degrees Celsius is 5. And of course you know that if you want to deal with volume of a cube, the formula is length times breadth times height. So that's going to be 5 times 5 times 5. All the sides are equal. But for you to find the volume, you need to multiply it 5 by 5 by 5. And that will be 25 times 5, 125. cm cube. So this means our V1 is 125 cm cube. And the question says you should find the new volume, but you were given linear expansivity. You cannot use linear expansivity alpha to calculate for cubic expansivity. Now, I have also done a video on expansivity. I did a video on linear expansivity, another on area expansivity, and another one on cubic expansivity. You can check the description to find the video. Now, there is a relationship between linear expansivity, area expansivity, and cubic expansivity. And the relationship is that your cubic expansivity, which is denoted as gamma, is equals to 3 of alpha. That means 3 times of linear expansivity. And your beta, which is area expansivity or superficial, is 2 times of linear expansivity. So when you are given a question on volume, which is cubic expansivity, but we're giving your expansivity as linear expansivity,